Welcome back to VQ Intel. In today's video, we're going to be working with finding limits with conjugates. The links to the companion worksheets so you can follow along are down in the description. So we're finding limits with conjugates. So if I look at this limit, I cannot find it with direct substitution. Let's check that just to be absolutely sure. If I substitute 0 in for x, I get square root of 0 plus 2 minus square root of 2 all over 0. Well, square root of 2 minus square root of 2 is 0 over 0. And anytime you have a limit where you have 0 over 0, that means, okay, well, they probably have a removable discontinuity. Now, how do we figure out what the limit is? In this case, we're going to multiply by the conjugate. Now, some books will say multiply by the conjugate of the numerator or the denominator. Well, it depends on where things are. So here, you just have x. So you can't really have a conjugate because you have to have two things that you're either adding or subtracting. So up here in the numerator, we have this radical, square radical 3x plus 2, and this radical 2. So what we're going to do is we're going to multiply by the conjugate of the numerator, radical 3x plus 2 plus radical 2. And we're going to do that on the top and on the bottom. Radical 3x plus 2 plus radical 2. Now, when you multiply conjugates, that's the same as multiplying something like x plus y times x minus y. You get x squared plus y minus y squared. And that's what's going to happen here. In the numerator, we're going to have this quantity squared, so the radical goes away. 3x plus 2 minus 2 all over x. Now, there's no conjugate down in the denominator. So we're just going to leave it as is. We're going to leave it as square root of 3x plus 2 plus square root of 2. Now we can simplify the numerator by taking plus 2 minus 2 and canceling that out. And so we're left with 3x on top over x times radical 3x plus 2 plus square root of 2, like that. Now, I can cancel the x's out, and when I do that, I'm just left with 3 in the denominator, and the numerator, excuse me, and in the denominator, 3x plus 2 plus square root of 2. Now, if I substitute in 0, I'm not going to end up with 0 on top, and I'm probably not going to end up with 0 on the bottom. If I do that, 3 over 0 plus square plus 2 plus square root of 2. So that is 3 over 2 square root of 2. And if I simplify that, I'm going to multiply square root of 2 on top, square root of 2 on bottom. So I get 3 square root of 2 all over 4. And so that is what this limit approaches. 3 square root of 2 all over 4. Now for the second one, same thing. If I substitute in 0, I get 0 over 0 plus 3 minus square root of 3, which is 0 over 0. So here I'm going to multiply by the conjugate, but this time the conjugate of the denominator. So square root of x plus 3 plus square root of 3 all over square root of x plus 3 plus square root of 3. So now the numerator still has x, but now we also have radical x plus 3 plus radical 3 all over. Now we're multiplying by the conjugate, so it's going to be this quantity squared, so the radical goes away. X plus 3 minus this quantity squared. So now x plus 3 and x minus 3 cancel out. So all we're left with in the denominator is just x, which is perfect because now we can cancel that out with the x in the numerator. So all we're left with is the expression square root of x plus 3 plus square root of 3. So now when we substitute in 0 in for x, we have square root of 3 plus square root of 3, so we get 2 square root of 3, and there is our limit using conjugates. Thanks for watching. If you want to support the channel, click the links down below. Remember, the best way to understand something is to do it.